engineers, you big dummies. I need you to come over here and solve this problem because it's killing me. I'm making 50 less widgets because this is going down all the time.
Welcome to Tell Me About It. This is the show where I interview various professionals to get insight into their daily lives on the job. My name is Josiah Smith. I'm your host, and today I've got a special guest, Kai Bailey, who, if you listen to the show, you may remember I interviewed a fire protection engineer named Connor Bailey. This is the older and wiser Bailey. This one has a better haircut and better facial hair. So we'll but besides that, this is Kai Bailey. He's an engineering manager at a door manufacturer. So Kai, welcome on. Thanks for joining the show. Can you give me a 2-minute elevator pitch for your job, what you do?
Sure. So I'm an engineering manager at a door manufacturer, steel door manufacturer. We make hollow metal doors and frames. Basically, I lead a team of manufacturing product engineers. We optimize production, solve problems on the floor from a manufacturing side of things. Continuous improvement is a big part of my job, leading what they call cost extraction or cost savings. We focus on both improving the jobs of people, improving machines, buying new machines, upgrading them to basically make everything more efficient. Electrical engineer by trade, formerly a controls engineer at a system integrator, but moving over to the management side in about a year and a half now.
Awesome. Okay, cool. So does that prior experience in electrical engineering and controls engineering, is that what led into this, or is this more of a pivot than like a continuation of your career?
Yeah, that's a good question. So as a controls engineer, I was just doing projects, and then I was able to work my way up to being a site supervisor. So I had, 6 to 12 people, depending on size of projects, working not directly for me since I wasn't a manager, but in direct coordination with me. And that kind of led me into the management side. I enjoy seeing people grow, seeing that vision for what they could do, and that sort of delegation. And then it was a promotion to an actual management position outside of the company I was at. That was a good move. It's a good move.
Nice. Do you have any certifications, endorsements, education that was required for you to get where you're at?
Required? No. But I do have, I'm a professional engineer with the state of Tennessee. That's in control systems. I do have a safety professional certificate, a functional safety professional. So I can design, implement, audit, basically machine safety systems, control systems, just to keep people safe, that type of functional safety. And then I do have my MBA, but that just helps me on the management side and financial side.
Yeah. So how did you go from being like, what was it that drove you to make that change from being like in it, we'll say, like drawing up designs and implementing designs, to being like, I want to stop doing that and watch other people do it? Is that a normal path for engineers, or were you kind of like, I need to get out of this and take a step back and have that more supervisory role?
Yeah, it's a good question. I get this question sometimes from younger engineers on what the career path could be. Mm-hmm. Right. So there's really two defined career paths within engineering, and obviously there's some exceptions there, but it's either you stay technical your entire career, your entire life, and become that expert. You are the guy that knows the thing. Or you step into the management side where you're then managing the technical people and you're doing the project management. You are more the organization. You still have that technical background, so you can kind of audit all the things. You know who's going to be the best at solving this problem versus this, and you have that all in your head. But it's either the technical or you like the technical management. Now, engineers have a skill set that is sought after because we like solving problems. So that kind of applies to a lot of different facets of different jobs. So an engineering manager could then become a manager of a corporation, could become a VP, could do all these things because they have that background. Not saying it's required or anything, but it's a logical step. So for engineers, you can either stay in management, go that direction, or you can stay 100% technical and move up. Senior, I'm blanking on what the principal engineer would be, like the top tier, depending on what the company is. But yeah, it was interesting. I really enjoyed doing the technical side. I felt I was really good at it. I really enjoyed working with people, solving problems. At the same time, training the maintenance guys or the other engineers I was working with, and then that kind of led me to, hey, I could train them and lead this team, which then led more into the leadership side.
Yeah, cool. So let's talk a little bit about where you work currently. So you said metal. Did you say metal and hollow doors? Is that what you said?
Yes, so hollow metal doors and frames. So you think about man doors, such as a door leading in and out of a hospital, the stadiums, the push bars you push to get out of a stadium or gymnasium. Those would all be from the company I work at. Anything of that nature. There's some elementary schools down the road we just did a big project for doors, and it's something that you don't think about because it's a handle that you just walk in and out. But if you go to Lowe's or Home Depot, you see all the different hardware that could be.
Mm-hmm.
Now multiply that by thousands of different manufacturers and thousands of different configurations. It becomes quite a problem.
So do you design, fabricate, and install? Is that what your company does, all of that, or are y'all just one of the steps in the process?
No, we're just we're just the manufacturing side. So if a customer has a design they want to do, or they're like, hey, I want this crazy thing, we'll find a way to make it. Or they could say, I want 1,000 of this particular thing, and we'll be like, okay, now, no problem, we can do it. The other side is like the actual frame side of that business. Those are actually two separate manufacturing steps, two different parts of the business that are kind of linked because it's kind of hard to install a door if you don't have the frame. Sometimes we get both, sometimes we don't, but yeah, in the end we manufacture both of those.
Based off of what you said, are y'all mostly doing like industrial and commercial stuff, or do y'all do residential? I guess I don't know a lot of people that have metal doors at their house, but...
Yeah, you think more of like storm shelters and that kind of thing if it's a residential type metal door, safe rooms. So the company that I work for is very, very big. So they have a lot of different companies with them, a lot of different divisions. So some of those companies are more specialized for residential. We particularly handle the commercial or industrial side.
Okay, cool. So then the office that you're working in, is it like do we picture like a big warehouse and there's office space inside, or are you more in like a HQ type of office setup and then the manufacturing is done offsite?
Neither actually.
Okay.
I'm at the manufacturing site. So outside of my office area is the machines that do the thing to make the doors.
Okay, cool.
So I step out there and I can help troubleshoot a press brake or a shear or just assembly lines in general. I have a team of engineers that are constantly solving problems depending on if it's frames or doors. But yeah, we're right there on the lines if needed.
Cool. Yeah, that's really interesting. I'm sure I'll have more questions, or I already have more questions, but I'll ask them as as they fit. So let's talk more about your specific role then at the company. I know you said you're managing people, a passion for like developing people and growing. What's the bulk of your time spent doing? Generally speaking, we'll get more into the weeds in a minute, but just generally speaking, what do you spend most of your time working on?
That's a good question. Day to day just kind of depends on what. So there's obviously it's a manufacturing, so machines can break down. Maintenance is the first line of defense for most of those things. Engineering typically tries to look at not the problem of how do we fix it right now, but what went wrong that caused it to be down and how can we prevent it next time. So there's a bulk of that type effort of Again, not so much me specifically doing that, but understanding what the problem is and who would be the best person to solve this or team. So those type of problems. Then you have in the automotive world, continuous improvement, or Kaizen is another word for it. The Japanese started a Six Sigma or Lean Sigma, if you've ever heard those terms. It's a way of essentially adding efficiency to manufacturing lines, cells, all these different terminologies that if you're in it, you're in it. But essentially it comes down to every process could be improved in some fashion all the time. There's always room for improvement. And room for improvement starts with going out to the line and looking at it and reviewing with an operator, with maintenance, all these different people of how could we make this better. We're always looking at efficiency. So if this part takes 5 seconds to make, what could we bring closer to the operator or to the machine to make it 4 seconds?
Gotcha.
4 seconds saves a second, and I could make 3 more widgets at the end of the day. So there's that, and then there's more of the long-term vision of what millions of dollars, hundreds of thousands of dollars do I need to spend over the next few years to get the efficiency to this? What piece of equipment is causing us the most scrap or downtime that I need to think about replacing?
Yeah. So then are you considering, if I'm spending those millions, how long before I've made those millions back and then increased?
Yeah. ROI is huge within the manufacturing world. How quickly can I earn my money back based on the problem that I'm solving?
Gotcha. And do you have like a set line where it's like, if I can't make it back in X amount of time, then I'm scrapping this idea and moving on? Or is there some wiggle room there?
Yeah, it really depends on how deep the pockets the company is and how long-term they want to look. There's things within manufacturing businesses, and let's just say it's your home in general. I know that I need hot water in my house. Water heater may cost a lot of money, but I know that I need one. It's just something that I have to do. Now, if I want hot water on my sink and it takes a minute for the hot water to get there, is it worth adding another water heater, or can I just suffer and wait the minute? Those type of savings and how I spend money is how the company looks at those type of financial transactions. Where's my best amount of money spent to recover the savings? We may have stuff that we just have to do at the plant that have to be upgraded in order to keep the plant running that they will spend money on. And there's things that's more of, yeah, you could get this money. You could, but I think you better want this other thing.
Interesting.
So if you think about a number of years, basically under 3 years of payback is kind of a no-brainer. Anything more than 7 years is something has to have, you really need it because there's no payback there, or it's just one of the things you have to do.
Yeah. Okay. And are you making those calls in your position, or is that something that's done like in a conference room, multiple people?
Yeah. No, I wish I made those decisions. I wish I could just have access to the cookie jar, but no, it's every manufacturing engineer who's listening to this, all 3 of them, will.
All 3 of them right now. Give it a. I don't know.
We'll know what I'm talking about when they have to essentially present or prove out why this money is deserved. Again, it depends on the company. It depends on the amount of money it is. Say it's under 50 grand. It's not really a big deal. Just go ahead and buy it. There may be some approvals you have to do, but it's fine. $10 million, $20 million, that probably has to go up to a very high level within a company. Maybe even the owner has to say, yep, I'm willing to put the money out for it. The MBA that I have really prepared that because I can think it now as a financial side. If you think about cash flow in a business, you think about depreciation of assets, you think about the amount of money that you spend on a capital side versus how much you do have to depreciate that against the product you're making. You really start having to make those decisions. As a young engineer, I'm thinking, this is a problem we deal with every day. They won't give us, $100 grand to fix it. Well, 100 grand, maybe, turning on the lights at another facility. So it's, it's interesting.
That is interesting. Okay, so let's talk about then your kind of your spot on the organizational chart. So give me like one or two positions that are like report to you that you have influence over, and then a couple steps above you, where do you fit?
Sure. So the company that I work for, I said, is fairly large, global. 50,000 plus people who typically will buy companies and then integrate them together into different divisions. So I work directly for, you could call it's the general manager of the company, or essentially the CEO of the company that I work for that's within the larger company.
Okay, gotcha.
And then I have manufacturing engineers, product engineers that work directly for me. I have some controls engineers, which are outside of maintenance, more doing upgrades to machines, helping maintenance solve problems. So I'm very much at a staff level, if you think about it. And then my coworkers are more of the, let's say, quality managers, director of operations that handles the ops side, value stream managers that are over the ops of the different lines that we have. I'm trying to think, the other HR managers would be on the same line there. Obviously, there's different expertise, there's different roles within all those different departments. But as far as like across the line level, that's where I sit.
Gotcha. How's collaboration work then? So you just said, like, you just named a couple of things that are kind of on the same level, I think was the verbiage you used there. So do y'all work together much, or is it kind of everybody stays in their lane, you're over those manufacturer and product engineers, and then someone else is over ops? Like, do y'all collaborate at all, and how's that collaboration work?
Yeah, we have to collaborate in order to make changes. To do any sort of upgrade, anything like that, you have to work with people. Ops side, so if you think about those different departments, each one has their own priority. Each one has the thing that they are most worried about at the start of the day and at the end of the day. Operations, their goal is to get the most product out of the door as quickly as possible with the least amount of manpower.
Okay.
Engineering's job is to figure out how we can make that thing for as cheap as we can or as quickly as we can without compromising quality of the product and anything related to employees, operators, that kind of thing. Quality then is now looking at the product and making sure that we're making the best product, conforming to our standards and specs. So each department has a different priority, and if you think about their different priorities, you have to play to those levers as you take on different roles and as you solve different problems. If the ops side has a machine that's always going down because of this problem, well, it's beneficial for them to go, hey, engineers, you big dummies, I need you to come over here and solve this problem because it's killing me. I'm making 50 less widgets because this is going down all the time. And then we're able to count, hey, we solved this problem. We're now able to make 50 more widgets per day. We are the hero, right?
Yeah.
Meanwhile, the ops guy going, I told you where the problem was. You just had to go fix it.
Yeah.
So you got to work with everybody. It's funny sometimes what people will focus on as their priority, and some things you just go, okay, fine. We'll do it your way this time.
Yeah.
I don't have a leg to stand on otherwise, but sure.
Yeah. And does that take just
concessions and compromises to be made?
That's what I was going to say. Is that just take like getting familiar with working with people? Like, it's just you learn, again, what's important to people, when to pull strings, when not to pull strings. Yeah. And that's like almost a talent on its own.
Yeah, absolutely. And that's why the engineering side is so difficult for some engineers to get into the management side, because you have to have that kind of political capital. Now, obviously, I'm not an expert and I'm still learning all throughout business through the people. I had a manager one time tell me there were 3 types of engineers. I don't know if I've told you this before, but I'm going to tell you.
No, anything that starts like I'm all for it.
It's 3 engineers walk into a bar. But there's 3 types of engineers. There's those that are socially competent. They can talk to people. They can talk to both non-engineers and engineers. Those are typically your engineering managers. I'd count myself as one of those. You can have conversations with people. You don't have to get super technical, that kind of thing. Level 2 is they are very good at talking to other engineers. They're very technical. They can, they can talk to non-engineers, but it's a struggle. They can do it if needed, but you kind of shy them away a little bit. And then the third kind is they're incredibly smart, but you stick them in a room, you give them a computer, and you feed them every now and then. Those are the guys that say, you go, I really need you to go fix this. I don't care how you do it. I know you can do it. I won't let anybody bother you.
Yeah.
And they're going to fix the problem. They're that technical, and those are the guys that typically go up the chain of engineering and say, I'm now a principal engineer. I'm that guy of the company.
Give me a problem, I'll fix it.
Yeah.
But don't talk to me while
Exactly. Yeah. Don't give me any tips. I got it. Don't just tell me what the problem is. And every single one of those 3 engineers have their strengths and weaknesses. And it's interesting. I got away from the question here, but it's interesting having to manage all 3 different versions of that.
Yeah.
Within the same department. And then you have some people that are in different departments that are also engineers of that same type caliber.
Yeah.
Yeah.
Is it better when they know where they stand in there, or is it more challenging when they don't know if they're in that 1, 2, or 3?
Yeah. If you think about those different levels, you have some people that, because they're socially competent, they know tactfulness.
Yeah. Uh-huh.
And you have some that you're like, there's no reason for you to go 0 to 100 on this thing. There's no reason I don't know how to communicate this to you, so we're just going to talk about it again.
Oh man. Okay, cool. So let's get more then into the specifics of what you do. So and it sounds like a large chunk, if I'm understanding. There's 2 maybe major areas that you work in, which would be the employee development or engineering development specifically for you, and then that kind of more big picture understanding and, I don't know, probably projection, whatever you want to call it, forecasting maybe, I don't know. So talk about within those 2 areas, what are your processes? Like, do you sit down with people for one-on-ones? Do you hold training sessions? Like that sort of thing.
Yeah. So those are, again, you mentioned it, two different areas. I do one-on-ones for people that are fairly new to the organization, new to me, just making sure they have a space to communicate problems and issues that they wouldn't normally come to somebody about. I hate the term open door policy because that makes me degraded a little bit, but if my door is open, people know that they can just come in, grab some candy, tell me a problem, or give me advice on something, and I have no problem with that at all. If the door is closed, I'm in a meeting, don't interrupt me, but even though they still interrupt me. And then there's the long-term side of things of, where should we be focusing our effort? What problem is something that we're going to be facing over the next 5 years that I need to have somebody starting to look at now?
How do you identify that? What are your, do you just have a punch list where you're like, okay, I'm going to inspect this machine today and I'm looking for XYZ that'll tell me how I make that determination?
It's funny, I had this exact conversation today, so I'm just playing through my head exactly how I had responded earlier. But there's 2 different ways of doing it within different companies. So there's way, say A, which is the strategic plan outlook. The company you work for knows the product they sell. They know based on volumes in the past, seasonality, or predictions of the future, they're going to make this much product. They're going to have, the customer is going to want this feature or this feature, and we need to make a plan for the next 5, 10, 20 years of growth to be able to make those features or those advancements. Then there's companies that don't really know. They have customers telling them what they should be doing, so they are focused on that. Some customers yell louder than others. So obviously the ones that yell the loudest are responded to the quickest. And then you have some where we just look at, in that same breath, you have some that look at past things that were ordered, and you look at the trends of what is being ordered, and you can kind of predict it. Those are two different strategic outlooks, and you place your activities different ways. If you have a strategic outlook, then all of your focus is on how do I get those things done? How do I make machines or buy machines or upgrade things that we have, redo processes and that kind of thing to hit that strategic outlook? Automotive is a huge part of that cycle. They know what model's coming out in 2026, 2027, 2028, and they do model changes every year, which means all of their machines have to be updated every year, or all the tooling has to be updated if it's a small, minor year change. They're very good at that strategic planning about what's going to be beneficial and when they need to do it. The flip side is you have companies that don't really have that strategic planning, not any fault for their own, but it's not something they've done before. Then you have to look at more of internal, of what am I suffering on a daily basis that I have to start upgrading? What machines are we fighting that we know are critical to this business that I just have to go improve?
Mm-hmm.
Both are valid. One is obviously easier to set goals for yourself and achieve goals. The other ones are how you can lose yourself a little bit by upgrading things that don't matter. So you really have to look at the whole broad spectrum of going, I know that this machine is 20, 30 years old.
Uh-huh.
The mean time between failure of this thing is increasing. It's taking us too long to repair it every time it goes down. We need to do something about it. Or you could look at it from a redundancy. I have this machine that makes a widget. Well, I only have one of these machines, and every time it goes down, I can no longer make the widgets. So do I buy a better machine to make the widgets, or do I add another machine that's a smaller machine so I have redundancy when it goes down?
Okay. And is that when you're looking at the ROI then? Like which one is worth it?
Do I want to make it faster and have one machine, or do I want to spend less money and have something that's slower, but in the event the other one goes down, I'm still able to run? All those different data, calculations, cycle times, all that sorts of thing has to come into play of where you put your focus. In the same conversation I had today, we were looking at a layout of the plant going, I know that we have this problem, this production problem, and in the future we need to be moving this machine, this machine, this machine, this machine in order to put everything in the same area. I need to buy this thing. What's the story here? How can I communicate that I need this thing?
Mm-hmm.
And then how you ask for it.
Yeah. And is the drive always this could get you in trouble, but is the drive always to automate more of this stuff to where you don't have to hire a person to do it? When we're talking, like, if we're just looking at numbers, profitability.
That's a good question. In different industries, yes. It's always a benefit to automate something. But the more custom of a product you make, the less automation you can do.
Okay, that makes sense.
I've been in a lot of different industries. I was trying to recount them on my way home today, but I've been in wire and cable, pulp and paper, mining, food and beverage, metal bending, I think is the industry I'm in now. Metal bending, yeah. I'm blanking on another one. But all those different industries, there's different level of automations.
Mm-hmm.
Think about food and beverage. Say you're filling a can of Coke, right? You don't want somebody with a bottle squeezing Coke into a bottle.
Sure, yeah.
That's all automated. Your operators are making sure the machines are running, and the caps that go in the tube to go down and screw out of the bottle, that's full. Right? So it's a very different skill set. When you say a door manufacturer, you have an operator that is bending the metal using a press brake.
Mm-hmm.
And they have to measure it because every single one could be different. Or they're monitoring a machine to make sure it is bending properly, so it's a different skill set. The more custom you get, the less automation you can have. It's not impossible to automate customization, it just gets very expensive. There was a interview I saw, Tesla, I think it was Elon walking through his Tesla facility. This was a few years ago. And he was talking about this bolt that had to be screwed onto this one thing. And they're like, we looked at a robot for it, but it's just too difficult for a robot to do. And so a person was in there doing it because it was just going to cost too much money to automate it without the confidence that it would work every time. Robots and automation are great when it's the same thing over and over again with a little bit of variation.
Huh?
Yeah, if you have to change constantly or fixtures change or you do product changeovers, that's really when you can't use any of those.
Interesting. This question just popped into my head. Talking about all of the evaluating, like things that need to be made more efficient, which I guess is everything, but when you're trying to decide the order in which to make things more efficient, has AI played any part in this, or is it starting to play a part in that sort of thing?
Yeah, that's a good question. So AI is really great at pattern recognition and a lot of programming tasks. I had it write a Python code for me the other day, and just it helped me even troubleshoot where I was going with it.
Nice.
And what the issues I had with it. But it's not good for like a hands-on problem, right? You have to feed it things for it to solve for you.
Mm-hmm.
It may be a day where it can look at a camera and analyze a video of what's going, but something still has to take the video. Something still has to tell it what it's doing. If we go through and we look at a tooling and we go, well, it's not bending it perfect, it's doing something else, that's not easy for something of AI to solve. A lot of the hands-on manufacturing engineering is going out to the floor, to the problem, solving that, and finding out what the root cause, doing sort of like we call it RCA, or root cause analysis. You could use 5 why analysis, but these are all just standard manufacturing terms. New design process, maybe AI could help with that, or existing line configurations if you give it all the data, but it's only good at what data you give it.
Right, okay. Yeah, so like recognizing new problems, it's not going to be able to do, but if you say like, this is what I'm looking for, can you find me how many instances that this exact thing is happening? That's an example of it. One that comes to mind that's going to be used a lot in the future that I think is already using now, but on the maintenance side or the engineering side, if I'm on the floor and I have, say, a bearing burnt up or something, I can type into AI like, hey, I have this so-and-so bearing. What are the root causes that would cause this to fail prematurely? Oh, okay.
And everything fails over time. What
Sure.
would cause it to fail prematurely? It's going to say, well, you didn't lube it properly. You used the wrong lube. It wasn't aligned properly to the motor shaft. Was on the load side. There's all these different factors to it that a normal skilled maintenance technician knows to look for. But if you don't have one of those, then it helps you do a root cause analysis. I went to a reliability conference a couple months ago, and there was a company there that did this. They made their own AI that was a root cause analysis, troubleshooting AI. And I'm just like, well, there's a million of them out there now that you just use. But same type principle is, I don't know how to solve this problem. It gives you a step-by-step troubleshooting approach for it. Outside of that, cameras will be used for AI for different processes, but your system has to be very automated first. If I wanted to recognize patterns within a manufacturing process, it will be great for that. But otherwise, on a manual process, it won't be useful yet.
Interesting. Okay, so you're walking the floor, or you're looking at the process, and you identify something that needs to be priority one to improve on. What's your next step?
Well, priority one means either machine's down or I'm making scrap parts. And then again, depending on the line, depending on the part itself, depending on the urgency of it, we could be making scrap parts on an order that's due 3 weeks from now.
Mm-hmm.
It's not a huge priority because the plant's not on fire or anything like that. There's other things that claim that. The order's due out tomorrow and I'm making scrap parts. Yeah, well, let's call some engineers. Let's go take a look at this. If it's a problem on a machine,
when you say making scrap parts, do you mean like you're trying to make doors for a client, and every door that's being made is not what they are going to use? Is that what you mean?
Well, by scrap parts, you could mean something is wrong with it, the machine damaged it in some way,
Okay.
or I did not make it to the specification that the customer ordered it.
Gotcha. Okay.
If they want the edge bent at an 87 degree and I bent it at 95, that would be over. So 90 degrees, right? That's not what the customer ordered. We're scrapping that, or we're going to find a way to bend it back. But a 9-foot door, it's kind of hard to bend that back to an 87. So what could we do to prevent that from happening next time within the realm of all the customization? So, just put priority on it based on, when is the order due, how big of a problem it is. If we're scrapping one door out of, 500 of them, it's not a huge priority. If we're scrapping 500 doors in a row, it's cause for concern. We need to shut it down and figure out the problem.
I think that was the the other Bailey.
That was the younger and more hairy Bailey.
There you go. Okay, so then we've identified the thing that needs to get fixed, the process, and then go ahead, keep going. I interrupted you. I'm sorry.
That just defines the priority, right? So, how many is it worth taking other people off of other projects, and where does that lie? And that's really where the manager portion and step highers of saying, hey, this is a huge priority. I don't care what everybody else is doing. We need to fix this thing. That's really where the manager kind of lives, is the delegation of resources to be able to solve the biggest problems and to get the biggest bang for the buck of using those resources. There's only so many hours in a day. There's only so many resources at your disposal, whether I go out there too, or we all team up and go solve a problem. We need to be able to kind of balance what's the benefit. Is it going to solve one door in a year? Well, we're probably not going to solve
a big deal.
that today. Yeah, that'll be some filler work in Thanksgiving weekend.
Right. So is that when you've identified it, you say, okay, we need to allocate resources to fixing this now, and then is that your call to say, oh, I've got Jim, James, and Joe here, I'm going to pull them off of what they're doing, put them on this project. Is your style, you're like, you guys need to fix this in a week, let me know when it's done, or are you like, hey, we need to get this fixed, let's meet a few times, tell me your plan? What does that look like?
Well, you just triggered me here. Meet a few times on an urgent problem is not a thing.
Okay.
If you have an urgent problem, it's like, let's go out there and let's figure it out.
Okay.
I don't want to have something down for 2 days and all we did was meet about it. That drives me crazy.
Gotcha.
People are like, I'll put a meeting in your calendar for next week. I'm here standing talking to you. Just talk to me about it.
Yeah, let's do it.
15 minutes. Let's go.
Yeah.
But yeah, it's calling, what do you say, Jim, Joe, and John, the triplets. Hey, come out here. This is more important. We need to handle this now. I'm going to stand out here. We're going to stand out here until we fix it.
Okay.
If we need to go back to our computers and do some drawing design, if we need to go order parts for it, whoever else we need, do I need to call corporate resources down and get their opinions on things? We've had a few instances of that where we've had a line down and it's just like, maintenance doesn't know what's wrong. We don't know what's wrong. We got to fix it. There's really no contingency plans here. So everybody and their brother come out here and let's just talk through what we've done, what we haven't tried, what's been done in the past, what does, all these different factors play into those type of things. But meetings are great when you want to, have collaboration. But yeah, anyway.
So it's very much like what you're doing then is very much just like real time. Something's broken, let's fix it today. Let's start working. Oh, next thing broke, let's fix that today. Like you're constantly.
Yeah. So the hair's not on fire all of the time because there's problems every day, but that's the reactive side. Sorry, I'm not over the carpet here. The reactive side to what you're saying, the thing is down and needs fixed. That's where maintenance shines. Maintenance is very much a reactive support function. They also are preventative in the fact that they do preventative maintenance tasks on machines to prevent the downtime, to prevent the reactive things. A very good maintenance crew is both versed in the reactive side and the PM, preventative maintenance side, where they have worked with the machine manufacturer, and the machine manufacturer says, in every 100 hours you need to lube this thing. Well, then they have on their schedule, in 100 hours I'm going to go lube that thing so it doesn't dry up and kill the bearing, and then we're down. So there's two sides of that coin, and then engineering side is more of what problem is occurring on a consistent basis that we need to go and fix so maintenance doesn't have to touch it. So the daily fires that we face are not that many because maintenance is there as the front line. We will solve problems that will prevent them from having to go out there or figure out that we need a new equipment or something of that nature to help that out. Now, I'm not saying that if something is down and they can't figure it out, then we will go out there absolutely. But it's not every second there's something. Now, there are days like that, don't get me wrong. There are days where every engineer is working on a fire problem, including myself.
Interesting.
But that doesn't happen very often.
How often do you have to step down and get your hands on it with the other engineers?
Yeah, I really enjoy that. That's something that I miss from stepping into this role. I've only been at this company for a year and a half, 2 years in March. So I'm not an expert of any sense of the word. Obviously, as a former controls engineer, I can step into the PLC programming side and those type of troubleshooting things whenever I really need to. So I really enjoy that aspect. If somebody's having a problem there, we can talk it out and go out to the floor, we can see what's happening. But the rest of it is more of, I understand that you are struggling to solve this problem. Let's just go out there, show it to me, let's talk it out, let's talk through what options are available. That's really where I get my hands dirty, is just, we need to go out there and show me what's wrong and let's talk through what hasn't been done. I'm an outside perspective, you're really in it, and sometimes engineers, when they get so involved in a problem they can't fix, they just get so angry at it and frustrated that they can't think of anything else. They get blinders on, and then you talk them and you're like, well, maybe you could try this, or you could try this, and they're like, well, we tried that, but maybe we can go try this. Okay, go for it. Let's try it. I'll stand out here with you. I'll order pizza if we need to. So let's
nice.
Yeah, let's do it.
That's cool. Tell me about what systems, not systems. That's all we talked about. What, physical tools, resources that you use in your job regularly. I don't know if you're at your computer very much, but what kind of programs are you looking at? What sort of things are you actually interacting with on a daily basis?
Yeah. Well, you have your basic Office suite, Excel, data analysis. In the Lean Six Sigma world, we use a program called Minitab. It's essentially a statistical analysis software. So I don't know if you know anything about capability studies, or if I have a machine that makes X part and it has to hold Y tolerance every single time, what confidence do I have in the machine that it's going to make that part 100% of the time? So those type of analysis, and then if you look at that and go, okay, well, we only have confidence it's going to make 95% of them correct. How do I get the last 5%? So there's those type of tools. Those are really getting in the statistics side of things, more of the lean side. What else are we doing? There's a couple ergonomic softwares out there. If we look at somebody who's picking something from the top and putting it down, picking up and turning down, and they're looking around and they're turning and they're looking around and turning, whatever the task is, how could we make that easier on them ergonomic wise? AutoCAD, SolidWorks for 3D modeling, those type of softwares. Just those alone, you can do a lot. There's nothing really specific around our industry that would need us to do anything super special outside of just 2D modeling, 3D modeling. Mm-hmm. On the control side, we're really an Allen Bradley house, like most of the U.S. So programming systems, pretty much all Allen Bradley devices.
That's a developer?
No, sort of, yeah, both. They make the hardware and the software to be able to program PLCs. Used to run the machines.
Okay. What's a PLC?
A programmable logic controller.
That's the thing that's telling the robot what to do?
So robots are a little different. The PLC is the thing turning on and off things in real time. So if you think about like on a machine, say it grips a part and then moves it over to the side. Well, the PLC is telling it when to grip it, how far to move it, in coordination with other hardware and devices and things.
Interesting.
It's basically thinking in microseconds about the next thing it's trying to do in some sequence.
Interesting.
They're very different than computers as far as the programming side.
Yeah. Okay.
And you really have to get into the control side to learn that. Most controls engineers either started as a maintenance background or they got into that somehow.
Okay. Yeah, and then okay, but you don't get to do that very much anymore because you're now mostly overseeing that being done.
When the controls engineers or maintenance guys really need help or something, or they've been out there all day, I'll go out there and help them, or most of the time I'll leave them alone unless they really have an issue, or if they are on vacation and I'm still there, that kind of thing.
Yeah, I jump in there and show the kids how to do this.
Yeah, I mean, so there's we have things at our facility that are new to some controls engineers. We have things that have been there a very long time. We have old systems. We have new systems, and none of them are typically the same. They all use different software, different ways of connecting with them and communicating with them. And if you
need to hire an engineer to figure out how to get all those things to work together.
Yeah, in like the 70s, 80s, and 90s, the hardest part about PLCs was connecting to them.
Okay.
You had to use like serial cables. You had to know what the baud rate of it was. You had to have the special connector and converter. I'm just thinking like SLC 504s. Those are like, it required a special card on your laptop, and then you had to have the special cable.
Nice.
And now everything is, on a Cat5 cable or Ethernet IP, and the IP address, you can type into it and connect to it, and makes everything super easy. But if you have a plant that's been around for 50 years, then you have kind of a mix of all of it. So
yeah,
if you've seen it once, and then you can recognize it again. That means you're just a controls engineer with on-the-job experience.
Okay, so take me through then. Quickly take me through a week, just like a Monday to Friday. Is every day the same, or do you have like a progression to your week that you try to stick to?
Yeah, I mean, Monday afternoons, I always do an engineering meeting with the full crew. Just if any sort of announcements or things I need to tackle, that's my time to really share that information. It's a time for them to really ask questions about what happened last week or things they're working on if they really need to. When I first started, I went through and I had everybody list what tasks they're working on, and it just became a boring meeting that no one really was interested in. So shortened it up, took that all out. So that's Monday afternoon. Friday is typically staff meetings, just kind of talk about the financial results of this week, what's on the docket for the next week and 2 weeks, and calendar events. In between there, it's just whatever meetings we happen to have. There's obviously monthly update meetings on capital projects, on cost savings projects, on safety events that happened, first aids, recordables, anything like that happened with operators. And then just ongoing project updates, that kind of thing. I don't know what it is, but Tuesdays for me is always back-to-back meetings. It's always Tuesdays are the worst. Nobody on this call cares, but it's just
yeah. Okay, so then going from that, then describe to me what a nightmare day for you in your role would look like. You don't have to be too specific if you can't be, but
yeah, I mean, a nightmare day is when there's a lot of things broken down and there's obviously not enough people to pull it together to help fix it. There's a couple machines in the facility that are essentially anchors in the facility, meaning they're there to stay and there's no upgrade path for them, and if they break down, they typically break down for a while and we don't really have a backup for it.
Oh, okay.
That would be a nightmare day. Yeah, just a lot of fires at once. And again, we don't handle a lot of fires, or I don't handle a lot of fires. Just more of those improvements. But if you get enough of them in the day, then it'll stress you out for sure.
Yeah. Then on the other side of that coin, perfect day. What's that look like, start to finish?
Perfect day. Well, I talked about the employee growth and why I enjoy seeing on the management side, seeing that change in people. I had one of my days today. I had a presentation today where I had just hired a new engineer, and we had an engineer that's working there for a while, and they're working on what the future layout and future capital for this area could be. And I'm in this meeting going, I can't find any fault with their plan, which means if I can't find something, that means the next level up and the next level up aren't really going to find too many holes, because I'm asking very deep, technical questions about why this wouldn't work. And if they're all prepared and there's no issues, this is fantastic. That tells me my new engineer is really getting it. He's now integrating really well into the group. Tells me my engineer that's been there for a while understands the problems that the plant faces, this particular area, understands that there's changes that need to happen, and he has somebody now that can go execute those. Seeing that growth and seeing that problem solving, and I didn't have to get in there and touch any of that or really help with any of that and guide a few things here and there. That's a good day.
Yeah, cool.
It's not always about solving the problems. It's about recognizing that there are other resources and there's other people that they are able to solve the problems, and it's a win when they're able to figure it out and solve it, which it just helps them grow.
Yeah. That's awesome. So if someone was listening to this and is like, man, that sounds like something right up my alley. I like what he's doing. What's a encouragement that you would give somebody as they try to traject themselves towards what you're doing?
In the engineering world, it's always worth exploring multiple different areas, whether it's manufacturing or it's design, in a bunch of different products and spaces. So things that I learned at Wire and Cable don't directly apply to food and beverage, but the methodology of their thinking does. Those type of troubleshooting, being on the floor with people, those type of things, that it really just crosses over. But being exposed to more problems and exposed to more people and how they solve things will get you a lot of places. And then just decide what type of engineer, if you're an engineer, what type of engineer you want to be, whether it's the super technical, love solving problems, love diving into data, love the design side, or it's worth stepping into more of those project leadership roles, solving problems, taking the lead, and then learning how to delegate and learning how to look to the future at what you're doing and what problems you want to solve.
Yeah, that's something I'm learning about engineering. Is it seems like I could almost have a podcast just on engineering, and I feel like I could interview a different engineer every single week, and it would be different.
Yeah, we all do very different things. I'm an electrical engineer by trade. My wife is an electrical engineer by trade, and we do very little crossover. Very little. It's just every industry is different, and every little jargon is different. Every little widget is different, and they all have different complexities with it.
Yeah.
Yeah.
Yeah, it's really interesting. Okay, so we'll wrap it up with this. This is my bonus question to you. It could be job related or not, but what is it that gets you out of bed in the morning?
Oh, that's a good question. Besides the kids running in, waking me up, I'd say it's solving a problem. There's always something new to go find and fix. I feel like that's the engineering core rule that I have to give. But it's always something new. Some days it's the same problem every day and that kind of thing, but eventually you overcome that, and then there's something new to go fix, and there's some new challenge that you haven't discovered that you can learn from. I always enjoy seeing people solve those problems, looking at something new that they've never touched before and going, I think I could do this, and then go, man, that was it. You did it. That was great.
Yeah, that's cool. Awesome. Well, thank you so much for coming on. I really appreciate it. That's engineering manager at a door manufacturer, Kai Bailey, the older and wiser Bailey.
That's right.
Thank you.
Right. All right.
Thank you for coming on, Kai.
Yep. All right. Thanks, Josiah.